Share the screen. Okay. Let's see if you can answer some of these questions. We'll go with number three. Number three, and you can write your answer on the chat. Which of the following mechanism transmits rotational motion in bicycles? What would that be called? You can go ahead and answer on the chat. Let's see. Yes. Sprocket, wheel, and chain. Excellent. Yep. So now a question I'm going to ask you guys. A sprocket, wheel, and chain, is that a transformation or a transmission of system? Again, is it transformation or transmission? Yes, transmission, because you're just doing a rotation from one gear to the next. Excellent. Okay, which one is it? Aha, number 5 is a good question. What mechanism is represented by the image to the right? Actually, at the bottom, not to the right. So go ahead. Let's see your answers. What is this thing right here? What do we call that? At the bottom, number 5. Aha. Yes, a rack and pinion. Good job, guys. Who was the first one to answer? Let's see. Michael. Michael's a fast typer. Good job, Michael. And is that a motion transmission system or transformation system? Excellent. All right, good job. Let's hear from Sachin. Can you unmute yourself?
Yep.
So good afternoon, Sachin.
Good afternoon.
Can you tell me in the drawing, you said this is a rack and pinion. Which part is the rack and which one's the pinion?
Well, the rack is the thing on the bottom.
Okay.
And well, the pinion's the other way.
Yes, it's the circle, the gear. The pinion is the gear. Okay, so can you explain why this is a transformation of system of motion?
Because the rack is moving up and down, which makes the pinion turn circularly, I guess. Yes,
excellent. Actually, I wanted to share with you last time, but I didn't get a chance to do it. Had we been at school, there's like a little system that I wanted to show you. Hold on, let me share this with you. Oh, don't freeze on me now. Where is it? Where's the video? 1 second. Oh, here. Do you guys see that? Rachel? Oh, Mateo, you don't see it? Okay, hold on. Okay. All right, you should be able to see it now. All right. This was from school. This was from school. So you see, I was turning the rack, the minion rack up and down. You can make this with full elevator using a rack now. And here's this using like a rubber type. Okay, since we're at this, hold on. Let me show you something else that I filmed from school. Where did it go? Oh, here. watch. So you guys write on the chat. Transmission or transformation? Good. Now let's see. Yes. Oh, what is it? Transmission system. You can look in your notes. Can't hear what? I can't hear the question over the sound of the video. Oh, okay. I can stop the video. The question was what type? Yeah, it's a pulley and belt. Who wrote that? Yeah, Michael, it's a pulley and belt. Okay. Good. By the way, if you don't know where we are, I was just reviewing page 100 in your blue notebook. And then we're going to be continuing with this right after. Okay, the other thing I wanted to show you from school. Let's see first. Where is it? Where are you? No. Where is it? It's not here. Oh, here it is. Yes. I won't sound. This was from school. Oh, this one. Come on, buddy. This. Do you see it?
We don't see the video, Miss.
What?
We see the screen, we don't see the video, though. We see the screen,
okay.
we just don't see the video. Like, we see it says prank video.
Here you go. Now you see it?
Yep.
Okay, so transmission or transformation? Transmission or transformation? Yes, transformation. And what would that be called? What is the system called? You have it on page 100. No, it's not a cam. Connecting rod and crank. Yes. Connecting rod and crank. It's one of my favorite. I like that one. So the one I don't have, when I went and raided the closet, I couldn't find the cam follower idea, but that we've seen it last time. If you remember, we had the Automata cam follower. This is one of my favorite motion transformation systems. Where are you? Let's see. Here's a cam follower. Oops. And they even show you how to make it. Okay, so let's see. You can write in the chat which one of these two items, the circle or the stick, is the cam. Which one is the cam? The circle or the stick? Good. Excellent. Great. So that being said, can you put a 5 if you understood the notion of motion transformation systems, and a 3 so-so? I got everybody here? I don't think I got everybody. Okay. If you have any trouble, please let me know. Don't just throw it under the rug and say, oh, doesn't matter. It matters. Please make sure you don't understand, you let me know. Okay, ladies and gentlemen, we will move on to speed changes. Page 100, 101 in your blue notebook. So this should be a breeze because you have a base from last year. And I wanted to show you, there are so many cool gears out there. The one that I'm very interested in is the gear inside a pencil sharpener, an electric one or a mechanical one. And I'm going to share it with you. Just give me a second. The gear inside a pencil sharpener.
Oh, hi, miss. Sorry,
Hi.
I didn't get the notification. If you sent out any, I don't know.
Notification for what?
For the Teams call. I only got it now or something, like telling me to go in.
Okay, well, it don't, like, it's always at 1 unless there's a special reason, but
Okay.
yeah, you don't have to wait for the notification, just come in whenever.
All right.
Well, you came right on time. I was just reviewing Facile Learning assignment, and now I'm about to start the new topic, so
Okay.
it's okay. You need your notes, page 100 and 101, okay?
Got it.
All right, so let me show you the pencil sharpener that I find interesting. So inside a pencil sharpener, you have a really cool mechanism. See that? And it's all gears. And we call them concentric gears. This is one gear into another. And you can even call them, that big cylinder one, it's even called a helical gear, which is a little different than your typical gears. So they show you really in detail how is the pencil getting sharpened. Thanks to the fact that it's helical, it's able to turn and cause the pencil to get sharpened. And sort of keep sharp. Yeah, I just thought I would show you an interesting gear that we never thought of. We never really sit and think about, what's inside of a pencil sharpener. Now into the notes, right here, page 100, at the bottom. Speed change. So in grade 9, the speed change, when we talk about gears, it's strictly qualitative, meaning we're just going to ask you if it's going faster or slower. I know some of you learned last year with Mr. Dufresne, you went a little further and learned about ratios. So that's great. But I mean, that's actually a grade 10 subject. So I'm just following what's necessary. Next year, you'll learn a little more. So for the speed change, it occurs, of course, in a motion. Can you highlight transmission system? Because again, it's a rotation that causes another rotation. There's no translation. It's all rotation through and through. So Annette, to repeat here, we talk about the driven component rotates at a different speed than the driver. The driver component, as a reminder, the component that receives the force, highlight receives the force needed for the system to start. And I highlighted start. Working and moving. So if you remember 2 sessions ago, I talked about the difference between the driver and the driven. Literally think about someone who's driving the car is the main source of movement. He's the reason why the car is advancing. Or in this case, the gear system advances or moves thanks to the driver who has the main source of movement. Okay? The driven is the passenger of the system. It's going to move only if the driver moves. Okay? So I'll just let you finish writing. I'm going to keep going down. We have also what we call intermediate component. It's found between, highlight the word between, the driver and the driven component. And not all systems have an intermediate component. It depends. Depends on the machine that has the gears. So typically here, look, it says without intermediate component. And here it's with the intermediate component. So this is simple. You have just the driver and the driven. And here you have an intermediate is in between. What's this 100? Well, that's the page. Okay. So the word that's missing here is different, start, and driver. Where's my oh. My kids played with the gears. All right, I'm just gonna remove the share for 1 second. So, as you remember, this lovely gear system. As I'm moving here, we have the green gear and the yellow gear. Can you write on the chat, which one is the driver? The green or the yellow? Which one is the driver? Yes, excellent. Good. Okay. Thank you. I have another system here that has various size gears. Okay. So my hand, this is a little harder to hold. My hand, see, I'm turning and they all move, right? And the intermediate is, as you guessed it, right in the center. These two are intermediate. Okay? Out of curiosity, which one of these moves the fastest? Let's see your answers on the chat. Let's see your answers. Yes. Excellent. Yeah. Same as here. I move this. The yellow one moves a lot faster. Excellent. Okay. Back to our page. We'll just finish writing and then move on to the animations. I have animations to show you. Okay. So moving on to page 101, everybody. 101. Why is this? Oh, it moved. That's why. There it is. So the speech change in motion transmission system depends on, highlight, depends on the relative diameters of the driver and driven components. When I mean relative, meaning in comparison with, like if I say this gear is bigger than the other gear, that's what I mean by relative to each other. Just remember that the smaller the gear, highlight, the smaller the gear rotates, the faster than the bigger gear. So you have three possibilities of speeds. You have the possibility of no speed change, and in this case, it's the diameter of the driven gear is equal to the diameter of the driver. So pay attention here. Even if there's an intermediate, the overall speed, like as if the intermediate doesn't affect anything, really as if it's not there, you really look at before and after. The driver at the beginning is the same size as the driven at the end. So that means that it's the same speed. Like this guy, again, everybody look here. Even though you have two other gears in the middle, pay attention to the speed. It's the same speed. The driver, which I was holding with my finger, and the driven, look at them, how they are at the same speed. So no matter what's going on inside, if I ask you what is the speed of the system, and you look that the driver and the driven are the same size, that means that there is no change of speed. Okay? And go back. Now, in the event that there's a speed increase, if you want it to go faster, the diameter of the driven would be smaller than the diameter of the driver. When the diameter of the driven component is less than the diameter of the driver, there is a speed increase. It's like that tiny gear that you guys paid attention to. You told me that it goes faster. So this is a situation where when you drive a car, and if you're driving standard, like stick shift, you actually have to, when you press the clutch, you have to let go, the gears let go. And then depending, if you want to go faster, then you cause it to change gears, literally, to a smaller gear. So when a car is driving faster, it's actually going with, it's using the smaller gears activated. And when the car is going slower, then the gear is shifted to a bigger gear. Okay? So you see here. So as the driver moves, because you have way more teeth, there we go. Because you have way more teeth here in the bigger, the driver, every time you do one turn of the bigger gear, the driven has to do X amount of turns. Okay, like this is why you guys learned about ratios. So let's say you had 20 teeth here and only 5, let's just say. This means that every time you do one turn, this little gear will do 4 turns, which is why it's faster. See that? Okay. Okay. Now, a speed decrease, the diameter of the driven is larger than the diameter of the driver. So when the diameter of the driven component is bigger than the diameter of the driver, there is a speed decrease in the system. I'll give you a minute to write this down. And I mean, you can say, you know, like, let's say we say the diameter of the driver is smaller than the diameter of the driven. It's the same thing. You can say either way. Like if you can read it this way or read it this way, it's the same idea. It's like saying my 11-year-old son is shorter than me. But you can also say, I am taller than my son. See, it's the same idea, the same meaning, but you can say it different ways. Okay. So let me just show you once again. Watch here. if my driver here, I'll use the this one's a little bigger. Watch here how when I spin the driver, like the yellow one now becomes a driver, it's smaller. The green one's a lot slower. Why? Every time I do one tour of this, the large gear only does like a partial tour, so it's a lot slower. Okay? Let's do some animations. You'll get the hang of it. That was it from that page, right? Yeah, it's not that much. So far, what do you feel about this topic? Can you put it 5 if you understand the gears, and 3 so I can repeat. Anything you need me to repeat, go ahead. This is the time. Great. Bravo, everybody. So let's look at the animations on Edumedia. They're really good. Just pull it out. 1 second. All right. This is great. I love this activity. So we have chain. They show you examples of even in your bicycle when you change gears on a bicycle versus just regular gears like that. Okay. So let's hear somebody in the class today who's with me who would like to participate. Mariella, are you there?
Yes, miss.
Hi, Mariella. How are you?
I'm good. How are you?
I'm good, thank you. Okay. Tell me, Mariella, do you see the gears, first of all?
Yes, I do.
The animation? So
Yeah.
you see it says you have on the left number of teeth on the driven gear, okay, which is the yellow one, and number of teeth on the driver. So the driver is the blue one, okay?
Yes.
So pick any combination that would slow down the system. Slow down the driven. Tell me what I have to do. I need to slow it down. What do I have to do? Mariella?
Yes.
So basically, you're picking here, look, the size. See that?
Yes.
So pick anything. Go ahead.
So it would be 60. Or, yeah.
So you're picking 60 for the driven.
And
Okay, what
10
about the driver?
teeth.
Say again?
For the driver. 10
How
for
much?
the driver. 10.
Oh, yes. Excellent. That's very slow. That's like 1/6 of the speed. Excellent. Thank you.
Thank you.
All right. Hamza, are you there? Hamza going once. Hamza going twice. Hamza, wake up. Okay, I guess he's not there. Someone else, let's see. Let's hear, Josh. I wonder if he's awake. Last time he was sleepy.
I am.
You there?
Yeah, but I'm still sleepy now. To be
You
honest.
sleepy? It's 1:40. Wake up.
I know.
Okay, give me an idea. How can I make this system equal speed? What do I do?
Make both 60.
Okay, let's see. Excellent. Excellent. Very good. Can I do another example? Any other speed?
30-30?
30-30.
It just have to be same, that's it.
Exactly. It has to be the same. Beautiful. Thank you, Joshua.
Mhm.
Okay, good. You were paying attention. Let's hear Vivian. Vivian. Hello, Vivian.
Yeah,
Hi, how are you?
good. You?
Good. Okay, so what can I do now to increase the speed? I want to make this faster. What do I do?
You could put one of them. You could put for 10, and then the other one you could put 16. The smaller one's gonna go faster.
Okay, so this
Wait,
let's just be a little more specific. You have the yellow is the driven, or think of him as the passenger, and the driver is the yellow, the blue one.
Mm-hmm.
So which number do I put for what? To speed up the yellow one.
Oh, you could put like 60 for the blue one, and then like 10 for the yellow one.
Yeah, already just by doing this, you see how fast it's going? And the same with that one, even faster. Oh my goodness. So you see it says it counted for you, number of turns. So the small gear is going 6 times faster than the big gear. So this would be like, this would help if you're on your bicycle. Actually, let's try it with the bicycle. You see the same idea. So if you're trying to go faster. So let's see what happens if I change this gear. See? So it's still going faster. But I mean, slower than this combination. C'est bon? And this is equal. Anyone want to try anything? You can unmute yourself or put on the chat if you want me to play around with it. If you were at school, I would have you guys play around with it as you want. No? FYI, this website is called EduMedia, EduMedia Sciences, you see. And this time, because they're doing, because of the COVID-19 situation, they're actually giving free access for people. So there's a lot you could do with this. So it's really fun. There is more on gears on this website, like this unusual gears. It's really cool. You have all kinds of gears in the world. Look at this one. Depend on what it is used for. See? Then you have this one. All kinds of weird gears out there. And this one. And you have this one. I don't know why this one bugs me a little bit. I don't know. Just irritates me. Don't ask me why. It irritates me a little bit. I just feel like it's gonna fall or something. Boom. And they even do it in slow motion. What else do we have in here? Out of curiosity, in your chat, can you guys go ahead and write objects in your life that have gears in them? Let's see what you're going to write. Name some objects that have gears in them. Yes. Legos. Oh yeah, of course. Bike, old clocks. Bike. Okay, besides bike, guys. Your Xbox controller? Mateo, now you have to unmute yourself and explain that to me. How is there gears in an Xbox controller?
First of all, I accidentally spelled Xbox wrong. Sorry. Okay, let's see what. Well, oh God, I thought there were gears. There are gears. There's gears. There's friction gears.
I don't think so.
Yes. Wait, give me my new controller I bought.
Hold on. I have to get my son involved in this.
Oh no! Oh no!
Controller.
Well, there's friction gears with the. Wait, let me turn on my camera.
Please prove that to me.
So, oh, look at this beautiful controller. Okay. So you see, there's the friction gears.
Marky, I'm here. We're having a debate here. Hold on, Mateo.
Oh, God.
Mateo here says that there are gears in the Xbox controller. Is that true?
The friction
Okay, look at your controller.
with the sticks. See the
that's-
ball. Those are like gears, I think. Oh no, she's actually checking it. Oh no.
Okay, who's for or against Mateo that Xbox controller has a gear?
Xbox controller. Xbox.
Locks?
Locks.
Well, locks have gears. She's right. Let's see. Let's see if he's right.
Oh, I have the same
Everybody, this is Mark.
controller. Mine broke though.
Mark,
Hi.
this is my whole class. Well, they're not only 3, there's more. Okay.
Oh, I have that.
You're annoying.
I know.
There's a gear in there? I don't know. We'd have to take it
Yeah,
apart.
well, that's
Can I take
the
it
ball
apart?
joint. It goes quick. I have that too, but mine broke, and that's why I have this one. I bought this yesterday.
That's mine.
No,
It's-
so far I don't see signs of gears. I'm sorry, buddy.
Well, I suppose this is the ball joint, right? This is. I suppose this
Yeah, it's
could
a
be.
ball joint, but inside, I don't think there's a gear.
What's next? Let's break it.
No, wow.
He's gonna break it.
Okay, I think
Yeah,
I
but
lost
there's
this
no gear
one.
inside.
Yeah, I think I lost this one.
Seriously? Your parents will be very happy with you, Mateo.
Well, I thought there were gears inside. I thought the ball joints would be, but I thought there were gears inside as well, but no. Thank you.
Gears 5 limited edition. What is that, Gears 5?
That's the one with that.
Oh, it's just
video.
called like that?
Yeah, it's limited.
Oh, it's called like that, but it doesn't actually have gears. Wait, what is inside of Xbox controller? There we go.
No, undo.
That's my.
Oh, there's a nice. Okay, wait. We're gonna demystify your question there. Just one sec. Everybody, look here. That's
There
what
we
the
go.
controller looks like inside.
Ah, there's no gears.
There's no gears, only buttons, and some sort of motherboard.
I honestly thought there were some kind of gear inside. Well, no, I know it's all like circuit boards and stuff like that, but I thought like the joysticks would be gears.
But it's okay. I mean, it's a good guess.
What kind of Xbox controller player knows that there's gears inside? I
No,
should be
it's okay.
ashamed.
We have a picture.
I want to try. I want to see.
Don't break it. We use this when we play NBA. No.
No, this one's broken.
We don't play with that one?
No.
Okay. All right. I
Okay.
play NBA with my kids.
Oh, that's fun. That's a good game. Never got into it.
Okay. There's another really cool inside a bicycle bell. Inside a bicycle. Don't do that. Oh. This one's really cool. This was actually on an exam one year. Okay, let me share that with you. There it is. Inside a bicycle bell. You see that? You have some gears in here. Actually, it looks like a rack and pinion. It's a rack and pinion. See that? And you have some around your kitchen too. Can you think of some in your kitchen? I'm sure you can think of some in your kitchen. Ah, we have an answer. Yes, a can opener. Thank you. A pepper grinder. Vivian, all sophisticated with her pepper grinder. Good job, Vivian. Good. Okay. What else is there in here? I just have a salt pepper shaker. I don't have the grinder. It's okay. You don't have. You're gonna hurt yourself.
No.
He's still trying to undo his controller. Okay. What else? Whoa.
Don't
There
break the
goes
controller.
Okay.
It's a perfectly good controller. Don't break it. Not for science.
What in the name of science? I'm not responsible. Sorry. I did not tell him to take it apart. Mom,
I'm
Dad,
worried
it's not my fault. Anyway,
because there's nothing inside.
did you take it apart?
No.
No.
Well, I don't
Okay.
want to because I mean I could sell it. I mean, there's one that completely doesn't work and can sell it to a kid and rip him off.
You can
But-
sell one that's not working well? Come on, Mateo.
I'm joking. I'm joking.
I put it back together.
Oh, you did? Okay. What else we can play around with here? Gears again. Oh, they're just playing around here with the speed. So I'm assuming the driver is the larger one and the driven is the smaller one. Then they do gear train where you have a few. There you go. What else? There's a lot on this website. We have bicycle history. Interesting.
It's really cool.
Yeah. Do you see this, I hope? Uh-huh. Mateo, a clock. Yep. See that in 1860? What is a bike called? Penny farting? Okay. And a safety bicycle. There we go. And you notice how the gears, there's more like the last one has the gear and it's faster. You will watch that again. So they were starting to understand the ratio makes a difference. And then here, the last one, the safety bicycle, the wheels are the same, but the gears change. And that's what we have today. Okay. Anyone know if I'm going uphill, what would be the best way to have the gears placed? Like you guys can unmute yourself. Anybody know? I feel like Sashin would know this, or Michael.
Me?
Sashin? Michael. Yeah, if you're going uphill, how do you have to have your bicycle gears placed?
Wouldn't you reverse it?
Let's try it here. In here, do you see it?
Yup.
Uh-huh.
Um,
Reverse it? Oh, you think the back one should be bigger?
I
Yeah.
think so.
Yeah. So you see it, the front, already going uphill is hard. So if you make the front gear smaller, it's easier for you to pedal. But at the same time, because of the torque, you're putting in a lot of force on a small gear and all of it transmits to the back. So thanks to that, it's easier to go uphill. You notice sometimes people go really fast, like, wait, not like this. They're going way too fast for just a regular, like regular angle, like no hill or anything. That they would need to shift their gears. Anybody would like to add something on this? Michael? I guess not. What else we have here? Interesting. Gear sketches? Sketch. What are we supposed to do with this? Oh, we're supposed to draw. Oh, that's cool. Oh, wait. Oh, look at that. This is cool. I wish you guys can try this. You can erase that. If you go on the website and register, you could play with along with it like that. I can put the link on Schoology. You guys can try it at home. Play around with it. Yeah. So any questions about gears? If you understood gears and the speed change, can you put a 5 or a 3? 5 if you understood, 3 so-so. Great. So I'm gonna, before we go, just show you a bunch of things that I had from school. An egg beater. I'm gonna show this in a way that you can see the gears. You see that inside? It's hard to show on the screen. See the gears inside? And then there's even on here on this side. What else? Oh, who can tell me about the speed change? Faster, slower, or same? It looks like my eyes. You see that? Same, exactly. Yes, 1 to 1. Excellent. Look, it's my eyes are gears. Okay, next. Enough fooling around. Okay. You see this? What do you call the one that's here? I'm pointing at. What kind of gear is this one? Yes, intermediate. Excellent. Now, if we just look at these two right here, is the speed increase or decrease? Let's see. Yes, increase, because the smaller gear is the driven and it's going a lot faster. Excellent. You guys are fantastic. Really make my class, my time worthwhile. Very cool. Okay, now watch here. Speed increase or decrease? The driver is the one I'm holding here on your right. Speed increase or decrease? Let's see. Yes, decrease, because the driven is larger. Fantastic. So a little game you can play. Oh, I have gears at home. I don't know if you have gears at home. Had we been at school, I was going to have you guys build one of these little gear toys. Okay? So all you need is corrugated board like that. It's a gear puzzle. See, it says, I use barbecue sticks instead of screws. See? And then the challenge was to make a puzzle, to make it so that you have gears from one end to from one side to the end, from one end, sorry, to the other end of gears. And in this basket, you'd have a bunch, there's a bunch of them that would be placed like that. And if you have gears at home, can you put on the chat box who has gears at home? I highly doubt any of you have gears at home. It's too bad. Henrique maybe has gears. You have gears at home, Enrique?
Have Lego gears.
Yeah, Lego gears. You could do that too. If you have gears at home, you can make yourself get a piece of cardboard or a corrugated board like this, and with hot glue, you stick pieces of toothpicks or souvlaki bars, souvlaki sticks like that, and then you would add the gears here. See, like that. See, this is too big, doesn't fit. See, already I'm starting. Oop, and it fell. Hold on. So the challenge was to build the puzzle with the correct sizes. See? Oh, this is not going to work because that gear now is not moving. Anyway, obviously it's hard for you to do this while you're at home. At school, it's a different story. But no worries. Next year, there's a whole section on gears again, and there's a lab where you'll get to play with these. Oh, here, you see I started putting in the right order. See? If you remember in the museum that we went to on the field trip in December, there was a whole wall of gears where you had to like place gears next to each other so that they all move at the same time. So you just keep on playing with adding the gears so they all start moving. Anyways, oh, there you go. So I'll leave you on that one. On that note, you have an assignment on Facile Learning if you haven't done it already about gears. That is called, hold on, it's Unit 13, Lesson 4. That's the one that's related to gears. Okay. If you haven't done it, please go ahead. There's a few of you here that haven't done it yet. So please go ahead and get started. Ooh, I have more gears here, inside here. And look around you. There's lots of gears everywhere you go, inside all your tools, your objects in your house. Sounds good? So we'll be meeting again next week, Tuesday, and we'll do a review of tech, the older stuff. There is a section on electric engineering. I'm just curious to know who is missing notes. Page 102, because I could do electric engineering next time. Page 102 is one of the last things we did. If you're missing page 102, can you put on the chat? I'm missing page 102. Go ahead. Okay. So no problem. From this point on, it'll be review of stuff we did in engineering. We can backtrack to, let me tell you, hold on. You remember we did tolerances. We talked about exploded view, talked about visible line, hidden line, center line, dimension line. So we're going to review that stuff. I have a video made on all of that as well. I can put it on Schoology, and we could do like a mini test next time. What do you say? So, okay, not to confuse you. Next time we'll do review, and the following time we'll do a mini test. Yeah? All right. So, have a nice afternoon.
Same to you, Miss.